you. Another good morning, time to go. Oh, we are all looking for adventure. We are all looking for adventure. So, today we have an exciting guest from Aurora Propulsion Technologies. They have created the smallest rocket propulsion engine in the known universe. Small disclaimer, we obviously don't know all the universe, but as far as we know, this is the smallest rocket engine in the known universe. And so the slogan that you have is it's just rocket science. Can you elaborate a little bit what do you mean with the slogan, and what is it that you do?
Well, we are engineers by trade. So if you think about engineers as people who usually only have problems, this is actually not that big of a problem. It's just a lot of work. There's a lot of data behind it, and there's a lot of know-how that can be utilized from other industries, and bringing that together pretty much just piles up a lot of work, but the actual technology is not overly complex. Of course, that's our motto as well. We have to simplify our technologies to the maximum to enable the ability to manufacture in masses as well as in a cost-effective way.
All right.
So we say it's just rocket science.
Okay, cool. So we'll dig into the technology a little bit later, more in detail. But I'd like to tell to everybody that we are going to go through the following sections in this interview and or chat, call it what you may. So we start with the founder, then we talk about the technology, and then about the business, the challenges, the next steps, and the learnings, because I think those are important for all of the entrepreneurs and startup founders, regardless of the industry that they are in. So first of all, I would like to talk about Roope Takala first a little bit. That where do you come from, and what is your background? What brought you to start a space company?
Let's put it this way. I've been around, actually lived in 9 countries over my life, but my professional life, of course, started with the fact that I studied to become an engineer, a Master of Science in Technology, about 25 years ago or so, and went to work for a certain Finnish telecom company. Spent 20 years there in different roles. First in
which
research,
I guess is Nokia.
Yes, indeed.
It might be.
Rather well known around the world, in many people's pockets, and that was what was my first role in Nokia. I was building first factories, and later on I was doing research on user interfaces, basically the stuff that people touch when they use their mobile phones. I still enjoy the use of a mobile phone because I can see what patents our team made at that time.
Cool. It's interesting. It's quite far from what you do now. So how did it evolve? How did your professional path evolve to this direction?
Actually, it's not that far. It's an electromechanical device, as is a rocket engine. We are focusing. We are focusing on ultra miniaturization of technologies, which I learned in Nokia. We are focusing on extreme manufacturing capability, which was something we learned when we were designing mobile phones. How do you make thousands and thousands of mobile phones a day? Evidently, we don't need to do that with the rockets, but quality systems and these kind of learnings are pretty much the same. Also, space technology is regulated. How to run with the regulation standards is also prevalent in the telecom industry. So we have learned how to deal with how to run with the standard technology. So there's a lot of things that are similar. And of course, I would even say that space technology is quite simple. Nobody's going to drop it out of off the top of a roof, your technology, or onto a concrete slab and expect it to work after that.
What's your personal educational background? You said that you studied engineering.
I studied mechatronics. Mechatronics is a study of electronics, mechanics, control technology, a little bit of everything, so to say. Robotics is one of the targets of mechatronics, and it fits quite well into the space industry. After all, every spacecraft can be regarded as a robot. It has fully self-functional capabilities as well as remote controllability. Nobody's going to help move it around in space. It has to do it alone. So very much in that domain.
So let's go into the foundation of your startup. So
well, boys tend to have dreams. This dream I got when I was a very little boy, by 5 years ago, old or so. And I've been dreaming about building spacecraft since then. Of course, life took me in different places, but it's always been a little bit of stargazing in the back of my mind. And now I came into a position in my career where I had already founded several startups in other areas with other partners, done quite advanced technology in a large corporation, learned a lot of things, and I thought that now is a good time in my life to start pursuing my dreams. And what would be a better dream than making rocket engines, flying in space?
That's true. And also it brought you to the ESA Business Incubation Program, which you graduated from in 2020, right? So let's talk about the technology. First of all, what is and what are your main innovations, and what are they meant for, and how do they work?
Well, we do propulsion in space, as the company name Aurora Propulsion Technologies says. We do it in two ways. There's positive propulsion, which means move faster, and there's negative propulsion, which means move slower. We have two product lines, one for each one of these. We have plasma brakes that are a passive speed reduction mechanism that allows for deorbiting of satellites. And then we have a rocket engine product or technology that allows for attitude control orbital maneuvers of small satellites and movement in space in general. The technology itself is quite simple. We've spent a lot of time to simplify it. After all, it's only rocket science, so why not simplify it? And the technology we have selected out of the 256 or so different rocket technologies is what we call a resistor jet. It's basically heating up or using thermal energy in a material and a very small nozzle to create speed in the ejection to create thrust. So if you want to understand it simply, it's like your grandmother's teapot, the ones that whistle. Our rocket engines whistle as well, although it's an ultrasonic sound that you can't hear, and in space you can't hear it anyway because there's no medium, but it works in a very similar fashion. We heat up water or another chemical, xenon, krypton or whatever, which creates a lot of Brownian motion. We let it out of a small hole and that's it. It's like a kettle.
What kind of an engineering challenge it was to create it in such a small size?
It was huge. So the size of the engine is about 8 millimeters long and 4 in diameter. It's a cylindrical shape, and it's not only the engine. It's the nozzle, the cone, the heater element, and the valve to control it all in one package. And that means that it is very, very highly integrated and very miniature product. We have a team of micromechanics. Typically, these people work for companies like Rolex, Omega, Patek Philippe, making Swiss chronographs. We use them to make rocket engines. And they are the backbone of our company, how to make very, very small, super high quality components to enable this kind of technology to be manufactured.
What's a typical use case for let's say the micro thruster?
A typical use case is attitude control for a small satellite. Anything under, let's say, 150 kilograms in weight, we can address. We can fit the engines being so small into even sub-cube sized satellites, maybe a quarter of a cube. That would be 5 by 5 by 10 meters, 10 centimeters in size, weighing only a few hundreds of grams. And then the 150 kilogram satellites. For the smaller satellites, we can also do orbital maneuvers. Instead of just rotating the satellite, pointing the engines, we can also do movement. For the bigger satellites, we focus on the rotation, the attitude control. For the plasma brakes, of course, the whole use case is deorbiting satellites at the end of their useful lifetimes.
Interesting. I've seen those actually in person, and they are very impressive pieces of mechanics that fit onto the palm of your hand. It's very impressive.
The smallest engine we do is a single thruster, which in not just the thruster is the 8 millimeters long, but when we add the tank, the control electronics, the piping system, the fluid system onto it, it's a full 7 centimeters long and weighs about 30 grams. So that's the smallest engines, full engine systems available in the market at the moment.
So we already started touching a little bit on the business side of things. So what would you say so far have been the most important business milestones for your startup?
Well, evidently, business-wise, first key milestones are the funding of the company. Next is first deliveries, which we completed already in 2019. And then, of course, after that, we are starting to look at the revenue points in the milestones, which are starting to ramp up now as we speak over the year of 2021.
So when is the expected launch into space of Aurora Sat-1?
That's a good question. So the reason we made our own satellite as a propulsion company is we have a satellite killer technology, basically an end-of-life deorbiting technology. You don't want to be a rideshare with that because you'd be the last experiment to run. So we decided to build our own satellite so that we could speed the development of this plasma brake tether or the in-orbit demonstration. So we built our own satellite, which got delivered already in the summer of 2020. It was supposed to be launched at Christmas, but in space industry standard, it got delayed by 6 months. So we will be flying now in June 2021.
And that was the year when the shit hit the fan, and sometimes shit just happens and sometimes it hits the fan. And so you started the company in a lot of turmoil. There was global turmoil. How did this turmoil impact Aurora Propulsion Technologies and your plans?
Well, we were lucky. We had just concluded a funding round before for any bigger turmoil, but we did get a few hits from the follow-up funding, for instance, from Business Finland and the public funding sector, which went a little bit haywire at that point of time. Right. And we were lucky that we had planned the company so that we were not reliant on a single investor, but we had actually a rather large pool of private angel investors in the background who were able to help out in sorting out possible problems and delays, as well as with financial issues that might have arisen from delayed funding decisions and so on. So we were actually quite lucky that, as you remember, in the beginning of the COVID times, pretty much all venture capital shut down, but we could rely on our angel investors who were already in the company. Now, after 6 months of COVID, the VC market started to roll out again, and we were able to close a further funding round, just this building stuff, prototyping, which meant that we were not expecting to get customer funding at that stage, which evidently didn't happen for many companies over last year. It did cause some delays in some of the deals that we had expected, but now, since people are getting used to different ways of working, the business has picked up again.
So, what are your personal coping mechanisms when you face stress and adversity? How do you cope with it?
Well, usually it helps, leaning back a little bit, taking a long breath, counting to 10, and also when you're running a company, you have to multitask. You have 10 balls in the air all the time. Usually they all don't fall down at the same time, so you have to be able to compartmentalize. And also it helps if you know when to ask for help and how to do that. A lot of people want to help space companies or rocket engineers. It's also a dream for a lot of other small boys who have grown up.
Yeah.
So asking for help, taking a deep breath, getting up when you fall down. There's nothing much more to it. Help, having worked for 20 years in different industries, telecom, also in startups, helps getting to grips with the fact that every catastrophe won't kill you. Yeah. You just have to put it on side and figure out how to solve the problems. Well, those steps have already been started. So this current product portfolio will be demonstrated on this satellite that is now flying. We have procured 3 further flights for further development. Effectively, what we will do is we will increase the thrust capability so that we can address larger satellites with the engines, as well as larger satellites with the plasma brakes. It seems to be in the industry trend that currently there's a lot of very small satellites being launched, because a lot of the new players in this industry are trying their technologies and their capabilities with the small satellites, mainly for cost reasons. The next step is then that they are starting to implement their business cases, and usually that requires maybe more sturdy instruments on board. And typically that also means that the satellites grow to maybe 50 to 100 kilogram weight ranges. And of course we want to grow with these customers of ours.
All right. So also still about the business and next steps. Is there? Let's say that there are people watching this, people and companies watching this. Do you have a wish list of companies and partners that you would like to talk with or meet with?
Yes, I do. As in all industries, there are a few whales. Sometimes it's worthwhile fishing for a whale even though you don't get it. Typically these are the big prime companies in Europe and America. Then there are a few very large constellation companies, of course, that we want to talk to about deorbiting satellites at the end of their useful lifetime. It's an evident use case for them that will cause issues also in their ability to launch their vehicles.
Because there will be more requirements for actually getting rid of the space debris as well at the end of the usable life cycle, right?
Yes, currently the standard is that the spacecraft has to deorbit in 25 years, but there's already been some moves to bring it down to 5 years. That is a very, very tight schedule, and currently pretty much there is actually no satellite that can do that. Not at least not the bigger ones that are flying above 500 kilometer orbits.
Yeah, we'll actually put a picture into the corner that shows the amount of space debris, trash basically, orbiting the Earth at the moment. So even ESA has a program that and initiatives to get, you cannot easily get rid of it, but at least to try to get rid of it. And there are even startups that are tackling this. One of them actually graduated from ESA BIC Switzerland.
Yes, actually, I think the startup you're mentioning here is ClearSpace. And we are working, of course, with them to multiply their business case, not making a satellite like they are, but maybe helping them utilize these smaller deorbiting devices like plasma brakes to multiply their business opportunity. So there is interesting collaboration with the companies in Europe, and I would suggest that people keep their eyes open for things to happen. There's a lot of buzz going on in this industry.
That's correct, and there's also a nice cross-pollination happening between space companies that come from the ESA network, whether it is from ESA Business Incubation Centers or ESA network in general, and that's a great example. Now let's try to conclude this with some good advice that you would give to new aspiring new space entrepreneurs, not necessarily just space entrepreneurs, but startup entrepreneurs in general. What would you say to a young and maybe inexperienced entrepreneur who's willing to start a new company? I mean, what to prepare for?
Create a network and reach for the stars. You have to also enjoy the ride. When you set up a company, as you said, things happen. Sometimes you hit a roadblock. You have to find your new way. You have to have a target, a North Star to follow, but the steps you take, the directions you go to get there is probably quite unknown at the start. So you do have to enjoy the ride. We are also creating a solar electric sail, and that's a tool to travel to other planets and around the solar system. And it's apt to talk about enjoying the ride as in sailing. You never know where you end up, but you have to enjoy the way, the travel, because this is what startup is.
Yeah, correct. I think that was a great way to almost conclude this, but if you were to start this company today and you had all the learnings that you have accumulated, what would you do differently, if anything?
I think we have done exactly what we planned to do. I would probably try to focus more on ensuring a longer runway in the beginning, funding issues, even maybe postponing the actual development to work a little bit to make sure that there is not so much stress or there might be a buffer when stuff happens. But I would say that in practice that's almost impossible to do. Usually when you want to fund a company, you need to show what you're capable of, so things work hand in hand. But mostly things have worked out exactly as we have planned. No, there's been bumps here, bumps there, but if you take a helicopter view, things have gone pretty much well. So there's not very many things I would do differently. One thing I would always like to do more is talk more with my team, help them solve problems and make them feel valued, because that's always one of the things that you really need. A good team who can take ownership of problems, solve them, and the role for the leaders is to support.
Absolutely.
Try to give them 100% empowerment to do their stuff.
And also not be afraid to hire people who are smarter than you are, because that's why you pay them, right?
Well, I would be failing in my job if I hired anybody who was not smarter than me.
That's cool. I think this was great, and I wish you all the best for your space endeavors, and I'm sure we will be crossing paths again.
So I'm certain of that. Thank you.
Thank you.
Oh, we are